Hey all, this is my Earth Space Science Chapter 29 Stars Standardized Test Practice discussion. Okay, I'm on page number 858 in our Earth Space Science textbooks, and I'm just going to go through the standardized test practice with everybody as a group. And of course, you know what to do. You need to write down the correct answers as we go, and any other remarkable things that I say or write on the board, and then you will take pictures of that and send them to me via email. So you just handwrite into your notebook or onto loose leaf paper, whatever you want to do. But we're basically going to learn a little bit more about the vocabulary of stars that they have here in our textbook, and we're going to learn a little bit more about how to successfully navigate a standardized practice test or any test that you're going to have in your future. So that's why I want to go through these tests with you and have you write down the things that matter, and so you kind of get a feel for how to be successful on tests in the future. I love it that you're paying attention right now, and I'm thankful that you're listening. I hope you guys enjoyed the My Corona drumming and the prayer that we had, and I'm just going to give everybody credit for a bell ringer just because you're putting up with me today. I do love you all, and I know that learning is not always fun. So here we go. We're gonna do something that you might not enjoy, but at least we're talking about stars, and stars are awesome, as you know. God made them right where they are, and He knows every star that exists. He's familiar with them. He's holding them in existence throughout the entire universe for us. And I appreciate I appreciate how much God loves us, given all of that. Okay, so multiple choice question number 1. I'm on page again 858. So the first question I'm reading here from the book, in December, that's wintertime, right? Christmas, all of that. The South Pole is tilted closer to the sun, right? It's wintertime here in the Northern Hemisphere. So the Southern Hemisphere is experiencing summer. And the South Pole is pointed at the sun during the wintertime here in the Northern Hemisphere than at any other time of the year. And the North Pole is tilted its farthest from the sun. That sounds like a solstice of some kind, doesn't it? Huh. What is the Northern Hemisphere experiencing at that time? A winter solstice. Look at that. Question A sounds really good, but let's look at the other questions, maybe, or other answers, they might be better. The summer solstice. No, we are experiencing the winter solstice in the Northern Hemisphere. What is the Northern Hemisphere experiencing? They are experiencing a winter solstice, not a summer solstice. The vernal equinox. Honestly, I don't know what the vernal equinox is. That might be something we should throw out, since we know that the winter solstice sounds really good. And the autumnal equinox. Okay, now maybe I'm starting to know what an equinox is. Maybe it's that transition period between winter and no, I think the winter solstice is when is that when spring begins? No, that's not when spring begins. That's in December. That's January and February are the 2 coldest months of the year, is what I always remember. So anyway, I'm going to go with A. Number one, the answer is A, the winter solstice. The autumnal equinox and the vernal equinox, I'm not sure what those are, so I'm throwing those out. And the summer solstice is not true. Okay? Number two, which planet is moving fastest in its orbit? All right, so the three planets in the picture above are Mercury, Venus, and Earth. And the question is, which planet is moving fastest, okay, in its orbit? Mercury, Venus, Earth, or the Sun? Well, the Sun is not a planet, so throw out D. So now we've got Mercury, Venus, or Earth, okay? And I'm not sure what they mean by fastest in its orbit. Do they mean kilometers per second in terms of travel around the Sun? I know Mercury travels several times around the Sun every time Earth travels once around the Sun. And I can't remember Venus. Seems like Venus travels faster around the Sun than the Earth in terms of revolutions per Earth years. I think Venus, but it might be Venus is slower in terms of revolutions per Earth years than the Earth is. Obviously, Earth is one revolution per year. So, I'm guessing here. I think they want us to, I would think the answer is Mercury, because it travels 8 times around the Sun approximately every time Earth does. I remember that by watching the video of the solar system. They got Mercury flying around the Sun. But I don't know if Mercury is that much closer to the Sun, so that when it goes 8 times around the Sun in one Earth year, does it actually travel farther than the Earth does? I don't know. I'm not sure. So that's a tough question, but we've talked about it enough. And let's go with A, Mercury, on number 2. Okay? Which orbit shown has an eccentricity that is closest to 0? Okay? So an eccentricity that is 0 means there is no eccentricity to it. That means it's a perfect circle. And both the foci of the ellipse are on top of each other at the center of the circle. So which orbit shown has the eccentricity that is closest to 0? It looks to me like Venus does. Venus's orbit around the Sun does not look very oval, if at all, in that picture. So I'm going to go with Venus on number 3. So number 3 is B. Okay? Number 4. A bed of sedimentary rock is formed by sediments. Sedimentary rock is formed by sediments. Sounds right. That were deposited at a rate of 1 centimeter per year. How can you have a layer in the earth that's deposited over time? I mean, A bed of sedimentary rock is formed by sediments that were deposited at a rate of 1 centimeter per year. If the bed is 350 meters thick, how long did it take for the whole bed to be deposited? Okay. So, let's say you've got this cliff, all right, off this mesa. There's a mesa out there in the world, and you've got this waterfall, right? Big high waterfall, higher than 350 meters. Let's say this is 500 meters, which is a pretty high waterfall. All right, so you got this waterfall coming off this enormous mesa over here to my right, and maybe some mountains way off in the distance feeding across the mesa, feeding to this waterfall, okay? And there's this cliff. And over here, you have a hill, all right? And a river that flows out of this enormous lake that forms, natural lake that forms here. I'm sorry, this hill would have to be a lot higher. Let's go this way. So what we're going to end up with is a bed that's 350. So here's 500 meters down to there. That's 500 meters. So 350 is going to be about right here. So this hill has to come up to here, up to 350 meters. And this is and there's a discharge of the lake that's worked its way out of this hill. You guys can't even see where I'm drawing. Sorry. I'm over here drawing. All right, so this is 350 meters above the whiteboard, right? And now this waterfall now just falls down to here, and the water runs across this flat spot and out there. And all of this now is filled in with sedimentary rock. All right? And we know that this gets deeper by 1 centimeter per year, right? And the question is, how many years equal 350 meters times 1 centimeter per year is upside down. Now what we have to do is we need to say 1 meter is 100 centimeters, and then we have to say 1 centimeter per year, right? Is that how it went? We're on question number 4. I'm going to read it one more time. A bed of sedimentary rock is formed by sediments that were deposited at a rate of 1 centimeter per year. If the bed is 350 meters thick, how long did it take for the whole bed to be deposited? Okay? 1 centimeter per year is filling up this lake, okay, and the water is running off, and so this is it. We could use there's meters that go away. We could use a calculator to do this, but I think we can do it without a calculator. So this is going to be 35,000 years. And that's 350. Add 2 more zeros to it because you're multiplying by 100. So that's 35,000 years. Okay? Make sense? Okay, so that's what's called dimensional analysis. That was another example of using dimensional analysis this year in Earth Space Science. So 35,000 years is answer C. Okay? Now, which gas giant planet is the largest? Well, I think we know that Jupiter is the largest planet in our solar system, so I'm going to go with A, Jupiter. Right? Which energy source does not come from the sun? Wind, water, geothermal, ocean. I think that's a strange question, but we're going to have to logic our way to the best answer, okay? Does water come from the sun? What about water taken to a higher elevation by water becoming a gas in our atmosphere and then cooling off as it goes to higher elevations and raining down on the earth from above? Is that energy source dependent on the sun? I think so. So you might say that water energy, like on a sawmill or a hydroelectric dam or other things, you could make an argument that that energy is from the sun, because it's not like we're able to pump water to the top of a mountain and let it run down the mountain to a dam and then run it through a hydroelectric power plant and use the electricity from that hydroelectric power plant to pump water back up to the top of the mountain. That doesn't work. That's called perpetual motion, and because pumps and electric motors and generators of electricity from hydroelectric power generation plants, all that stuff, it does not have 100% efficiency. So you can't say that water energy can be produced by something other than the sun. The sun must produce the water energy that we use. Okay? What about wind? Does the sun, what if we didn't have a sun? Would we have wind on the earth if there was no sun making thermal currents? And, you know, I do believe that if you notice at night, the wind is greatly diminished a lot of times, unless there's some sort of a thunderstorm or something like that. But you'll notice on average, the wind is greatly diminished at night versus daytime. If you go out at night, you'll see a calm, much more calm circulation of air. I think that the sun creates wind, definitely. So wind energy is from the sun also. Geothermal. That's where you send water deep down into the earth and you get steam, evaporated water, high pressure coming back at you, and then you use that high pressure steam to run a steam turbine to create electricity, and then you recondense the water and pump it back down into the earth. Geothermal energy cycle. So does that come from the sun? Well, that might be, it depends on who you ask. I think the center of our earth is hot because of Earth's materials of construction are radioactive. And I don't think the center of our earth is hot because the sun is shining on the earth. So that might be one of the best answers, geothermal. And then there's the ocean, D, the ocean. Ocean, so what energy source does not come from the sun? Well, if the ocean waves are created by wind, and wind is created by the sun, then the energy that we get from ocean waves that's pretty cool. You ever seen those machines that sit on the bank of the ocean and they create electricity because the waves make a big arm go up and down, and that creates you can get electricity out of that machine that the waves are making go up and down. That is a really cool idea. Ocean energy, wind energy, water energy, and geothermal energy. I think geothermal energy is the best answer for number 6. Okay? Number 7. Which can you conclude from the graph? Okay, so what's this graph? This is population in billions. We're up over 6 billion, a little over 7 billion now, as a matter of fact, in 2020. And so you see this population increase with time from 1950 to 2005, it looks like. Maybe just 2000. No tick mark there to evaluate that. So population in billions versus years, okay? And which can you conclude from the graph is a question. In 80 years, it will not be possible to feed the population. No, it's not really a true conclusion from that graph. World population increases at a rate of 1 billion people every 10 years. Is that right? Let's see. We went from 2.5 billion to a little over 6 billion in 60 years. Nope, it's not a billion every 10 years. That's not the slope of that line. There were approximately 2.5 billion people in the world in 1940. Okay, that might be a conclusion that you could make from that graph. I'm not sure that would be an accurate conclusion, but it's possible. At the present rate of growth, the population will exceed 7 billion before 2020. I think you could conclude that. I like D. I think D is the best answer. So when you extrapolate that curve all the way out to 2020, what you might see is 8 billion instead of 7 billion. But really all we have right now is 7 billion. So this is one of those graphs that they were using several years ago to scare people thinking that the earth is overpopulated and we've got to have abortion and euthanasia and greatly diminish human dignity with vice in the world, pornography, alcohol, illicit drugs that you can use, and other things. So we've got to damage the value of humanity in order so we can kill people. This was one of those graphs that they were doing that with. The reality is, in 2020, we have just over 7 billion, and this curve is flattening. And the reality is, if we get to 8 billion, we may, but that won't be for a little while yet, another 10, 20 years. And at that point, the population will flatten its growth and then actually come down. And we actually have everything that we need for 8 billion people already today. There's no need to panic about overpopulation. People start dying as fast as they're being born, bottom line. And so the billions of people on the earth can't be much more than 8 billion because of the fact that people die as fast as they're being born at some point, right? I mean, isn't that ridiculous to think that we can't see that mathematics? All right. Of course, over a lifetime, a person can have more than 2 children. A married couple can have more than 2 children, and the population can continue to increase over the course of time. But when it becomes more difficult for people to live on the earth, or whatever, I don't think that the magic number is 8 billion. I think we could go all the way to 30 billion before we even start being concerned about where am I going to live, where are my children going to live, how are my children going to eat. Are you hearing me? There's really no concern. We're probably not going to get much above 8 billion though, because people are afraid of overpopulating the earth, and we have abortion, and we have euthanasia, and we have murder, and we have diminished human dignity to the point where people don't get married and stayed married and have children and raise children together, husband and wife. We're far from that right now, and I'd like to see us get back to the place where we're all living as we should, as Christians, and large families become the order of the day. It's not raccoons that are going to save the earth from a natural disaster. It's going to be human beings. I'd like to think that we're on a road to population growth, and I don't fear population growth at all. Okay, so I like D for number 7. 8. Based on this graph, what can be assumed about the carrying capacity of the world? Well, based on this graph, what can be the carrying capacity of the world? The world is in a state of equilibrium. No. The world has not reached its carrying capacity. That's true. The world has reached its carrying capacity. Nope. The world has exceeded its carrying capacity. Nope. The world has not reached its carrying capacity is the truth. B. 8 is B. On the graph, what is the year considered? Well, it's on the horizontal x-axis. So what is that? It's time. That is considered the something variable. Well, let's see if the answer's here. The constant, no. The dependent variable. The independent variable. The variable. I think the independent variable is the right answer. I believe the x-axis holds the independent variable that the scientist changes, and then the dependent variable on the y-axis follows the independent variable on the x-axis. Okay? Number 10. What causes sunspots on the sun? Well, there's something in the material makeup of the sun that comes to the surface, and a sunspot is actually a diminishment of solar radiation in the visible spectrum. That's why it looks like a darker spot. Okay? So let's read the answers. What causes sunspots on the sun? Intense magnetic fields poking through the photosphere. Charged particles flowing into the solar system. Could be. Number A and B are about the same in terms of possible right answer. Spots on the surface of the photosphere which are hotter than the surrounding areas. Areas of low density in gas of the sun's corona. Man, those 4 answers are all 4 possibly the best answer. We've got to figure out which one of these is not true or less than the best answer. We've got to put these answers in value order. Okay? Intense magnetic fields poking through the photosphere. That sounds really good, and why would an intense magnetic field poking through the photosphere make a sunspot? Because it would pull charged particles back to it. And so the radiation coming from that particular spot on the sun would diminish the amount of radiation, including visible light spectrum radiation. Okay? So A could be right. Charged particles flowing into the solar system. Boy, you know, I would think charged particles flowing into the solar system from the sun happen no matter what, and I don't think that is a sunspot. I think that's normal operation of the sun, so I don't like B as much as A anymore. C, spots on the surface of the photosphere which are hotter than the surrounding areas. You know, I think something that's dark on the sun is not hotter than the surrounding areas. I don't like C as much as I like A anymore. D, areas of low density in gas of the sun's corona. Areas of low density in gas of the sun's corona. Low density of gas. Well, now, I can see how that would become a dark spot on the sun because low density in gas, I ain't buying that one. That doesn't make any sense whatsoever. There's no such thing as a low density in gas on the surface of the sun. You know what I mean? That ain't right. I don't like D as much as I like A. Let's see if A's right. 10 is A. Look at there. All right. So A, intense magnetic fields poking through the photosphere prevent light from escaping the sun in that area. Okay? All right, number 10 is done. Number 11, what do we got over here? Describe the process shown above. Let's look at this. Here's a picture. I'm looking at this picture right here. Okay, that's a picture. let's see, there's carbon in soil, there's carbon in organisms, there's carbon in oceans, there's carbon in the atmosphere, there's fossil fuel burning, putting carbon in the atmosphere, and then there's carbon in rock. Okay? So what is this process? This is some sort of a carbon cycle, or carbon, let's see, describe the process shown above. Well, it's contributors to carbon dioxide in the atmosphere, or carbon in the atmosphere. Not really, it doesn't say carbon dioxide. These are both contributors and then things that happen to take carbon out of our atmosphere as well, mostly in the form of carbon dioxide. Okay? I think that would be a good description. The book says, the illustration shows the carbon cycle in which carbon is taken in by organisms from the atmosphere and is deposited into Earth, where it is incorporated into the soil. It is then used by organisms or stored as a fossil fuel until it is emitted back into the atmosphere. I agree. But I think our fossil fuels all come from a single world catastrophe of Noah's flood, and the coal and the oil that was created by burying in a short time period all the plant life, all the animal life, everything except what was on Noah's Ark got buried in a very short amount of time. And it turned to coal and oil under the ground, and that's what we're digging up today. But the reality is our burning of that fossil fuel, one, we've only got another 50 years worth of fossil fuels to burn, and then the fossil fuels are going to be so scarce near the surface of the earth that it's going to be hard to get fossil fuel, too hard to get fossil fuels for them to make sense, and we're going to switch to nuclear power. And whether that's fission or fusion, I can't see the future that far. But I do know that if we go with a certain type of nuclear reaction to make heat, to make steam, to make electricity, to make energy distribution easy across the surface of the earth for our use, to have air conditioning in our homes, for example, or to have refrigerators in our home, or electric ovens, or electric hot water heaters. Of course, some people have natural gas piped to their homes as well in this country because we've got an awful lot of methane gas to use. So my point is that for creature comfort, electricity is in demand. And so when fossil fuels become more expensive than nuclear power is, because of all the regulation that nuclear power has to go through, then we're going to end up having nuclear power. And I believe that the years between now and nuclear power coming online are being well spent to determine the best way to create electricity using nuclear power. And then of course we've also got wind energy, we've got solar energy, we've got thermal energy, we've got water energy. We've got these things that we can also develop in parallel while we're running out of fossil fuels, while we're running out of inexpensive fossil fuels in the next 50 years. So my point in saying all of that is that there's lots of options, and it's up to human beings with human dignity allowed to develop their own businesses and properties to create business and sell electricity. Those folks ought to be able, we ought to let them loose. We ought to let them do what they want. Obviously they can't destroy the earth. We don't want them to destroy the earth. They can't destroy the earth is the reality of it. We can always fix the earth. We're people. We have big machines. We have lots of power and energy. Just because we have an oil spill in the Gulf of Mexico doesn't mean that things are going to go extinct. We can keep that from happening, and you saw that happen over the last couple of years. We have opened up the Alaskan grounds. It's all national park. We're letting people have access to Alaskan national park areas, and we're going to let them drill the oil out of the ground up there underneath our national parks. What if we have a spill? We can clean it up. We can plant trees. The caribou will come back. We're not going to make the caribou go extinct, nor are we going to make the elephant go extinct, nor the whale, nor anything of interest. And the way we do that is we allow people to ranch those animals, and they never go extinct. All right. So anyway, subdue the earth. Jesus didn't personally. I mean, he might have been the one talking, but I'm thinking it was probably God the Father that was talking in Genesis chapter 1. He said, "Go forth, multiply, subdue the earth." He's given it to us to take care of, and we should take care of it. I do not think we should abuse the earth, but I also know that it's okay to subdue it. All right. So question number 12. Why is burning fossil fuels an important part of this process? Well, if we don't dig the fossil fuels out of the earth and burn them and make steam and electrical energy more cheaply than we otherwise could, then gasoline and electrical energy is more expensive, and people can't necessarily afford to buy potato chips if electrical energy is more expensive. So why is burning fossil fuels an important part of this process? So that people can buy potato chips and Reese's Puffs. Are you following me? I mean, I'm being a little facetious. People don't need Reese's Puffs or potato chips. We choose to buy them. And why do we choose to buy them? Because we can. And why can we? Because we have gasoline and electricity and natural gas and other utilities that are available to us that make us more productive than we otherwise would be. And we can literally afford to sit on a couch and watch television 6 hours a day. And what are you going to do if you don't have Reese's Puffs and potato chips under those circumstances? Are you following me? It's a matter of, it's capitalism. And it's how rich do you want to be? And how do you want to live? And we all make choices. And it's not immoral. It's not immoral to use electricity if we're willing to share the wealth that's created by it. Are you understanding me? If you're willing to share the wealth, tithe with a charity or a church or whatever, or you're willing to put in the extra time that you have rather than sitting on the couch for 6 hours a day, that might be a little bit immoral. And if you don't go out and spend at least 10% of your spare time helping others that don't have it as good as you, then there is maybe a moral problem associated with doing nothing for 6 hours a day. Now, if you're learning if you're getting a master's degree in earth space science, then that's not a bad way to be. Okay? You following me? But that's a ridiculous question. Number 12. Why is burning fossil fuels an important part of this process? Did you hear why I think that's a stupid question? Burning fossil fuels is not an important part of the carbon process of our natural earth. If we didn't burn fossil fuels, that would be okay. If we burn fossil fuels, that's okay, because there's an awful lot of carbon in our atmosphere, whether from volcanoes or power plants. I mean, you can't believe it. You just can't believe how much carbon is put into our atmosphere through natural processes. And what man is doing is negligible. 5% of the carbon going into our atmosphere is from man. Okay? And at least that was the number I remember from a long time ago when I was studying this stuff. Number 13 on page 859, number 13. Why are there two arrows between carbon in the atmosphere and carbon in an organism? How does a corn plant grow? If we didn't have carbon in our atmosphere, even a small amount, we've got 700 part per million carbon. That's less than 1%. If you have 1,000 part per million, you have 0.1% carbon in our atmosphere. Is that right? Yeah, that's right. Very low amount of carbon. Why is there a very low amount of carbon in our atmosphere? Because pine trees grow. Corn grows, soybeans grow, watermelon grows. We breathe. Actually, we add CO2 to the atmosphere when we breathe, right? I think we should all hold our breath. Why would a minor temperature increase caused by global warming pose a threat to Earth? Isn't that an interesting question? I don't think it does. It does not pose a threat to Earth. What if all the ice melts at the North Pole? Is our Earth put out? Will elephants go extinct because the ice melts at the North Pole? Will polar bear go extinct because the ice melts at the North Pole? Heck no. Those baby seals will be easier to catch on the shoreline because mama seals and daddy seals will have to come to the shoreline instead of be out on the ice having babies. They'll have to come to the shoreline. Think how dense baby seals are on a shoreline when there's no ice. They walk up. There'll be more polar bears than ever. Less seals. There will be fewer seals. But will they go extinct? No. Has the Arctic Ocean always had ice over the course of our planet's history of 10,000 years? I say no. I think we've got evidence for the fact that that ice didn't exist in the days of Noah. Are you following me? So, subdue the earth. Take care of the earth. But raccoons are not going to take care of the earth. People will. People will take care of the earth. What would be the harm of having 2 watermelon crops a year? I can't think of one. But the reality is we're not experiencing global warming today. Right now we've begun a cycle of global cooling because of the 11-year cycle of the sun where it's sunspots and those, what are those things that the sun throws off? I'm drawing a blank on the name for that now too. I'm sorry, I draw blanks on names. But you know how the sun will throw off flares, solar flares. The sun throws off solar flares, which actually creates more radioactive energy leaving the sun than otherwise. But when you have a diminishment of solar flares, you have a diminishment of solar radiation leaving the sun. And that's the cycle that we're in right now. We're in an 11-year cycle where the sun's surface activity is going to be diminished compared to the previous 11 years. And we're actually going to experience a reduction in global temperature here on the Earth because of it. An appreciable reduction of temperature planned or estimated over the next 10 to 11 years. Okay? And as I say, we're going to run out of fossil fuels in 50 years. We're going to have to change to nuclear energy if we want to continue to have creature comfort that we enjoy today in refrigerators and air conditioning and, you know, I mean, think about it. 80 years ago, grocery stores were not air conditioned. Schools were not air conditioned. Houses were not air conditioned. They had ice boxes in refrigerators. They would get a big cube of ice and put it in their refrigerator, and that's how they had refrigeration 100 years ago. And where did that ice come from? That ice came from people collecting it during the winter and then selling it during the summer. I mean, it used to be pretty low tech. And the earth didn't suffer. All right. Nor did earthlings suffer. We all enjoyed one another. We had fun, even though we couldn't plug in a refrigerator into the electrical outlet on our house. Didn't have one. All right. Why is an express lane for cars with multiple passengers a good form of energy conservation? Well, fewer cars on the road, burning less fossil fuel, right? Makes sense. We should have fewer cars if we can. There's no reason not to ride share if you can, and still have good job performance, be able to stay late if you need to, right? There's reasons you can't have ride share. But at the same time, if you can, that's cool. And I think it should be done. We're not to abuse the earth, but we are to subdue the earth. And that does not mean abuse. That means take care of it, right? And the money that you save not buying gasoline for your car because you're ride sharing, make sure you give that to charity. And not to a bogus charity. Give it to a charity that's helping people to find Jesus Christ. Follow me? All right. Here's a reading for comprehension problems. Sunspots alter the amount of energy Earth gets from the sun, but not enough to impact global climate change. I ain't buying it. The sun's responsible for an awful lot of energy on the earth. A new study suggests, okay, so this new study suggests that when the sun changes its output, the earth doesn't change its input. Come on, people. The sun's role in global warming has long been a matter of debate and is likely to remain a contentious topic. I'll buy that. Sounds like. Scientists have pondered the link between the sun and Earth's climate since the time of Galileo. There has been an intuitive perception that the sun's variable degree of brightness, the coming and going of sunspots, for instance, might have an impact on climate. Sure enough, most climate models already incorporate the effects of the sun's waxing and waning power on Earth's weather. The number of spot cycles over time reaching a peak every 11 years, but sunspot-driven changes to the sun's power are too small to account for the climatic changes observed in historical data. That's a claim. I'm not sure. I've seen evidence to the contrary, or I've seen conclusions to the contrary of that conclusion. That's why I call it a claim. The difference in brightness between the high point of a sunspot cycle and its low point is less than 0.1% of the sun's total output. Thank God. That's according to somebody and their measurements. What can be inferred from this passage? Okay, this is an interesting one. There's 4 answers here. Let's see which is the best. Sunspots on the sun do not affect global climate change. You might infer that from that passage. I don't. Of course, I think the passage is bogus based on what I know. And who am I? I'm just somebody who's been paying attention over the years. 17b. Sunspots greatly alter the amount of energy Earth gets from the sun. I don't think I would infer that from that passage that I just got done reading. Although I do agree with B. I think B is correct, but the passage I just read does not support that. It has long been thought that sunspots change Earth's climate. I agree. I still think it. I think one could make that inference from that passage that we've just read. The amount of energy output from a sunspot changes drastically during its cycle. I don't think I could infer that from that passage. So it's either A or C. Which one do you think the book likes? I think I like A. Let's see what the book says. Yeah, the book thinks it's A. But that's biased. That's a bias in a answer, if you ever saw one, to conclude A based on that passage is written. That passage was biased. Let's put it that way. The passage that we read was biased. All right? I find that interesting. Here's question number 18. Approximately how much does a sunspot cycle change the energy output of the sun? 0.1% is the answer. C, according to the article we just read. While a sunspot does change the amount of energy Earth gets from the sun, why does it not impact climate? Well, they say it's negligible. But I say over the course of 11 years, Earth's climate has been changing from warmer to colder and from colder to warmer since the beginning, since God created the Earth. The Earth climate has been changing. And what reason is there for that? Is it just volcanic activity? Is it the sun's radiation changing over time? Is it, there are many contributors to it, okay? And I'm quite sure that volcanic activity has demonstrated that it can affect the Earth's climate. I argue with the claim that man's activity of burning fossil fuels today, all these fossil fuels were buried in a single year into the Earth, and they didn't decay as they would have over the next 100 years. Right? They've been under the earth now for thousands of years, and now we're bringing them out of the earth over hundreds of years. So the fact that we burn fossil fuels on the earth has little or no impact on what would have happened on the earth. Are you following that logic? So anyway, that's where I'm at. Hey, you guys, I really do appreciate you hanging with me, paying attention to the standardized practice test, and I ask that you put down all the remarkable comments and take some pictures of it and send them to me, and I'll give you credit for taking the standardized practice test this fourth quarter during distance learning. I love you all. I really care a lot about you. I don't want you to get abused by people that don't love God. But you know what? We're gonna get abused by people that don't love God on this earth, because we're not going to mistreat them. And we need to count it all as joy. We need to love our enemies as ourselves. We need to pray for our enemies. Let's do it now. Heavenly Father, we know that there are people in the world that would love to take power and tell us how to live our lives. And of course, they They sneer at us who have faith in you. And I can understand why, because they're under the influence of the one who hates you, I don't see how anybody can look around and not see you in the force that holds the nuclei of atoms together, in the force that holds the electrons in a cloud orbiting around the positively charged nucleus. I don't see how anybody can look at gravity and the attraction that mass has to mass, or the electromagnetic force that occurs when we create a magnet, or even the Earth's magnet. The Earth is a magnet, and the Earth protects us literally from ions coming from the sun by diverting those ions around our Earth, and so we don't get bombarded by alpha particles or electrons coming into our atmosphere, like they do if they're in orbit around the Earth outside of our atmosphere. They actually have to be concerned about that kind of radiation. They can die because of a sunspot radiation from the sun. And people act like sunspots don't affect us. Of course, the magnetic field around our Earth is protective of us, but I hear them. I know them. I know what they want. They want me to stop driving my truck. They want me to stop running my central air conditioner in my house on a hot summer day. But they'll have their air conditioner on. They won't be bothered by the rules they make. Father, forgive them. I love them. I don't want them to go to hell. I don't want them to pretend like they know best either. I ask you to bless them. Bless them with humility. Bless them with true knowledge of you, because that's all that really matters. In your mighty name, Jesus, amen. God bless you guys. Have a great one.